Everyone, am I audible?
Yes, sir. Good evening.
Yes, sir.
मेरी आवाज आ रही है?
Yes. Yes.
All right. एक मिनट दो मुझे. I'll share my screen very soon. All right. So thanks everyone for joining the session again. Let me start the recording as well. Okay, please let me know if my screen is visible to all. Is it visible?
Visual, sir.
Thank you. All right. So we discuss about this packet flow. Okay. So as we are going to discuss some topics which are very important for us, right? And in today morning also we have discussion about that packet flow, right? So to just giving the right approach so that in future when we start doing the next level of the configuration and troubleshooting, we don't have any kind of the issues. So we have to understand the interface level of configuration. For that, as I mentioned in the morning, in any interface which is going to configure on the Palo Alto Firewall, right? Let's suppose this is my Palo Alto Firewall. So this Palo Alto Firewall have the multiple type of the interfaces. Even we have seen in the actual firewalls. Let me show you again. So Palo Alto A20 Firewall, which we actually gone through the console and the management access.
मेरी एसी नहीं चल रहा है एसी नहीं चल रहा है
Please mute yourself. Let me open it. Okay, so you can see, as I mentioned, right, in every interface, whatever the interface we have this gig interface, that is a 4 gig interface we have. Then after we have the fiber interfaces, that is the GB interfaces. So we can connect the SAPs, and also we have the HA interfaces and the management interfaces and console interfaces, right? So the zone is very important. Why it is important? This zone concept is going to give the zero trust architecture of the security. What does mean zero trust architecture? So any interfaces you are going to configure, any type of interfaces, it's the layer 2 interface, layer 3 interface, virtual wire interface, tap mode interface, sub interfaces. In all scenario, this zone is going to play a very vital role. All right. So how this zone is going to play a vital role? Because it is going to just segregate your network traffic, which is going to come from the one zone or might be the one segment, one LAN subnet, whatever you can think about it, one department. And by default, it is not allowed to talk to another department, another subnet, another kind of the set of the policy which is going to deploy. So this is the key concept of the zone. I'm going to explain again in the diagram representation how it is going to look like. But in overall, zone is the very crucial thing, and we should understand this definition. So if you go and learn about the definition of the zone in the Palo Alto or might be the official documentation, the way it has been explained quite a little bit complex to understand, because it is going to say that security zone are the logical way, right? Logical way to group our physical. What is the physical? That are the physical interfaces. These all are the physical interfaces, or the virtual interfaces. What is the virtual interface? Like I have the loopback interface, we have the VLANs interface, we have the tunnel interface, we have the sub interface. These are the actual virtual interfaces. And what is the physical interface? That is the RJ45 connection is going to happen, right? We have the fiber connection, it is going to be happen. That is the physical interfaces. So security zone are the logical way to group a physical, this is the physical, or the logical virtual interfaces on the firewall, and that must be associated with the some name of the zone, which is going to help you to control your traffic traversals from one zone to another zone, right? I'll explain how it is going to happen. And also it is going to capture the logs, what is going to happen between two different zones. That means, in short, whatever the interfaces we have in the Palo Alto Firewall in regard to the physical interface or logical interface, you have to configure a zone. Means each interface must be configured with the zone, and zone could be any name and any number you can define, but it should be looks like a logical name and number. It should not like I can go and put any name and number that has no meaning. Like with example, let's suppose this interface is connecting to the ISP. This is the WAN ISP, and this interface is connected to the LAN. This is my switch. So if my switch is connected here, client is connected here, ISP is connected, Google server is connected. So if I am going to connect the cable RJ45 on this port and also RJ45 on this port, so I have to give the name of the zone, which should be meaningful. What could be meaningful? This could be the WAN zone. This could be the LAN zone. This is the more generic LAN and WAN. If I want to give some another name, like the outside zone or the internet zone, this could be the inside, right? This could be the DMG, or might be the LAN, might be the trust. It could be any name. So we'll see how it is going to be classified, but every interface must be associated with the zone. That is the prerequisite. If you are not going to do that, the interface configuration is not going to serve you to just like sending the firewall traffic from one interface to another interface. So this is all about that normal interfaces, which is your LAN or WAN could be connected with a fiber or copper cable. Okay. But we have another interfaces also. You can see this is the HA interfaces. This is the management interfaces. This is the console interfaces. So in HA interface, no need to configure a zone. You just have to note it down. No need to configure a zone. Without zone, it is going to work. In management interface, no zone configuration is required, because by default it's the management interface. If you want to take the GUI access of the firewall, you have to use the like RJ45 from one side, and another side your PC is going to be connected, and you can take the GUI access of the firewall. Similarly, if I want to take the console of the firewall, so definitely it's we have seen live how it is going to be take a console on the real firewall. So we have to use the RJ45 to serial cable, and further this RJ45 serial cable need to be converted to the converter, which is the serial to USB port. That is, one end is going to connect on this particular interface and USB is going to connect to your laptop. So this is going to give the like the console connectivity from the Palo Alto Firewall to your system, so you can easily take the console access to the firewall. So these ports, HA ports and the management port, console definitely it's not part of the race of the zone configuration. So you also no need to define a zone, but rest of the interface it is going to require the zone. Is it clear to everyone? Zone is just going to help to segregate the traffic. Let me explain how it is going to do that so you can understand. Let me meanwhile start some firewall labs also. You have to use that. So I'm going to start some labs. Layer 2 interface mode labs. So let me open this lab, okay? Or better, I can open another lab which have the more meaningful design. So let's suppose this is your firewall, right? This firewall have the multiple interfaces. Okay. So as per definition, I mentioned that the interface which connected on the internet, this is required the zone. The interface which is connected on the DMZ zone, right? It's also required the zone name. The interface which connected with your LAN trust, that is also required the zone. But this is the management interface. Zone is not required here. Okay. So on management and another is the HA ports are not required a zone. Rest of the traffic, whenever it is going to process, that always required the zone. So you can see here, if I'm not going to configure the zone, so basically Palo Alto Firewall basically operate or process the traffic based on the zone, right? Zone always going to come in a picture. Without zone, your traffic processing is never going to be happen, because we understand we have the access control list and we understand we have the policy. ACL can be used in the router and switch, but policy is the extended version of the ACL, or you can talk big brother of the ACL. ACL have the limited matching criteria. You can match your layer 3 address, layer 4 address, or limited some application that is going next level, and some protocol numbers. But when I talk about the policy can match the layer 3, layer 4, protocol. You have to match the layer 7. Guys, please mute. Someone is talking. In addition of that, you can also match the content. You also match the URL. You also match the device ID, right? You match device type, user ID, and etc. So you have the multiple option in the policy. Means you can real time content you are going to match. Based on the content you are going to apply the filter. Based on the layer 3, layer 4, layer 7, means the application layer you are going to apply into the filtering. User ID, device type you are going to match, and based on device type, user type, you are going to apply and filtering. So how zone is going to play in between? Let's suppose this client want to talk to this client. What is the source IP? In this case, source IP is 192.168.10.10, and what is the destination IP? 172.16.10.10. So the packet is going to be formed from this PC. One is the source IP address, just giving the example, destination IP address, where 192.x packet, 172.x packet is going to be there. The first packet is going to land to the firewall and check the routing. Do you have the routing? Because when we are going to do the packet processing, as we understand in today morning, so this packet processing is going to check based on the slow path, fast path, right? So packet is going to enter in the fast path to check the session we have or not. If there is no session, then packet is going to land in the slow path. So slow path, the first thing is going to check is your forwarding lookup, right? And while doing the forwarding lookup, the routing is going to check, and the same time they also going to check from which interface the traffic is coming and which interface the traffic is going to exit from the firewall, and what are the zone associated between these two interfaces, right? So routing, interface, zones, all are going to be checks in the first place. If there is no routing, there is no further processing is going to be happen for that particular packet. No NAT, no policy checks is going to be happen. The first criteria, routing should be matched. Then second thing is going to be happen for that particular packet. So in this scenario, my packet is going to come from this particular PC. After coming this packet to the firewall, the routing is going to be checked. After checking the routing, the next step, they are going to check the policy. And in this policy, the zone is the very first criteria. I'll show you after the just explaining this concept. In the policy, when you create the policy, you have the source zone, means source IP with source zone, and destination IP with destination zone. So if you have the, let's suppose your packet is coming from DMZ and want to go in the trust, right? This is zone. Forget about the packet, source packet, destination packet are there. Routing is okay. So if the packet is coming from the one zone and want to go with the another zone, So by default, this packet is going to drop by the firewall. By default means this packet is going to deny by the firewall. This is the by default criteria of the Palo Alto Firewall. Why? Let me explain. So let's suppose, let me clean this. Okay, let me go in whiteboard. Let me open this. Okay, so let me clean this. So just think about, this is one of the big company. Just give me 1 minute, guys. All right, so what I'm trying to say, this is the big company. This big company have the multiple departments. All right, so these department having a different floors or different might cubicles, or might with OMC, or like the sitting area, whatever you can think about it. All right, so let's suppose this is the HR department. This could be the IT department. This is the marketing. This could be the sales. Okay, this could be the again HR. This could be the IT. This could be the IT. This is the IT, sales, marketing. So these are different department we have, and in different department, some different group of people are working. So by default, if I am the HR person, so I can simply have the Rahul, you have any questions? I think he is talking to someone else. So we have the different groups in the company, and different groups having a different kind of the sitting area. So if I'm the HR person, definitely I'm going to enter in this cubicle or my sitting area via this gate, right? This is the entry exit gate. Similarly, IT people can enter via this entry exit gate. Sales people are going to enter via this. IT again here, IT again here, marketing. This is sales. This is the again IT, again HR, again marketing. So by default, I am going to belong in the same department, right? So I have the full resource access of this department. Means I can talk to my departmental people. Means HR having the multiple employee 1, 2, 3, 4, 5, right? So I can talk to each other. There is no problem. Similarly, if I am the marketing department, I enter. So marketing have the various employee. I can talk to each other. I can exchange the data. I can talk to each other. There is no problem. Similarly, HR, IT again, sales having this, all are having a similar kind of properties. But let's suppose I am the HR person and I want to talk to marketing person, or I want to access this area, marketing area. Rahul, you want to ask something? Rahul? So by default, this access, when he is going to talk to this department from the HR to marketing, by default might be you have the access card. I'm giving the very layman example. So this access card, whatever you have, when you're trying to access this gate access, like the whatever the RFID or access card has been configured, particular this gate, the access is going to be denied. You all agree, right? Similarly, if this marketing guy is going to come in this HR department, his access is going to be denied by default, right? This is by default. So what does mean? Any inter-department people, any inter-department employee, inter-department employee cannot talk to each other, cannot access resources to each other. Let's suppose I have the subnet here 10.10.10.10, here 20.20.20.0/24. If this subnet people want to talk, either physically they want to access the gate, logically they want to talk from one computer to another computer, they not have luxury to exchange the data, talk to each other. There is some kind of the limitation. The traffic by default it is going to deny. So this is the one properties. But let's suppose this HR person want to talk with this HR department, right? So they are belong to the same family, same group, but might be the some region the sitting capacity of this department 30 only, so 30 people can sit here and next 30 can sit here. So they are in the HR to HR department only. Still might be they have the different subnet 40.40.40/24, but still by default they can access to each other. Okay, so you understand one layman example means I am belong to the same department, I can access the resources to the same department, there is no any issue. If I'm trying to access the another department like the resources, that is not possible. So this concept is known as the intra-department access, and this intra-department access by default it's allowed. This intra-department access by default it's a deny. You guys understand? So in this scenario, if IT want to talk this IT, the traffic is going to be allowed. IT to sales, this is going to be denied. Sales to marketing, this is going to deny. IT to IT, this is going to be allowed. Marketing to marketing, this is going to be allowed. So this is the normal layman property. I hope you understand this intra-department and inter-department concept. Clear to all? Give me thumbs up if it is clear to everyone. And this is simply correlated with the Palo Alto Firewall. So I'll just go and explain that if everyone understand this concept. Everyone understand? Yes, no, maybe?
Yes, sir.
Okay. So now we are good. Let me move to the firewall diagram. So you can see here. So in this same scenario, this is the one of the trust department. Okay. Just think in trust department, HR people are working. This is the DMG department, IT people are working. And this is the your firewall, that is your acting as a entry or exit gate. So you guys tell me by default if this PC want to talk to this PC, will they going to talk or not? If my routing is there, by default they are going to talk or not?
No.
No, right? Not allowed.
Yes.
Okay, but if I change this IT HR to IT again, this is again going to be IT, then what is going to happen? They talk? If routing is there?
Yes.
No, because the IP address is different, right?
I'm saying IP is different, so for that we require the routing. So routing in place. Only we're talking about the zone point of view. This again become the IT.
Yeah, they will talk.
Sir, but how they will talk? The IT department at one end is different interface. The IT department at another end is different interface, right? How they will talk? Like how the firewall will know? Yes.
Who is going to explain this? Anyone have the good answer to explain? Chandu, Amit, Astos, Lloyd, Suresh, Srijan, Arun, Trilok, anyone?
Because
Good
one
question,
side is
Chandu.
But they are connected on same zone and same firewall, so they can talk to each other.
But what is the
How
logic? How they are going to talk?
They inter-zone access.
Basically, it's a type of broadcast in the same broadcast domain.
No,
Right.
they are
Firewall
different,
is
different network. 192.168 and it's 172.16.10.0.
For
basically that zone
communication
is
between two different network.
Because
so
of
basically
My voice is audible.
Yes, yes, audible, audible.
the interzone policy.
Yeah. So first
Because of the
all, in
interzone
order-
policy, sir, it is configured in the firewall.
Interzone
By default.
policy.
Yes, by default policy of
by default interzone policy
One is
is allowed.
interzone, one is intrazone. Which policy is going to take? If I'm going to
In
make IT,
intrazone. Because of
intrazone policy will apply for this communication.
yeah. So, who asked this question? Chandu, right? So, Chandu, today morning we have done discussion. Any communication is going to happen. The first criteria is going to check is the routing. So, you first tell me if this is directly connected subnet on this particular interface. This is also directly connected subnet on this interface. So, routing is there or not?
Yeah, routing should be present.
So the second criteria is to check the NAT. In this scenario, NAT is not required. So you can bypass the NAT. The third check is going to happen with the policy. So do you have the policy in the firewall or not? With the same zone.
Yeah,
Yeah,
it's
policy
by
is
default
needed
policy.
because
Default
By
policy we
default
have,
policy
right?
is available.
Intrazone default policy we have, right, Chandu? We discussed
Yes,
today
yes.
morning. Yes.
yes,
Because of this intrazone policy, they are going to talk because routing is there, so policy by default open. But if it is going to be HR, then it is not going to talk. If this is going to be HR zone, then we have the interzone policy, which is by default everything is denied, right?
yes, yes.
I'll show you after some time, so you understand. So because of this zone nature, we have some restriction. You cannot talk with a different zone, but with same zone you can talk to each other. So is it clear about the zone concept to everyone? And this zone is going to apply with all the interfaces. Okay, shall I move next?
Yes, yes.
Okay, so let me move to the next. So the first thing we have to understand how this zone is going to protect the traffic from one interface to another interface by layer 2 deployment. And what is the layer 2 deployment? Also we have to understand. So let me log into this firewall. Let me see what is the IP address of this firewall. So the IP address of this firewall is 254. So let me try to log in. 192.254. So we'll see the examples how the traffic is going to be happen. Okay, so let me simply do one thing. There is already some pre-configured policy. So let me delete these all. I'll explain this. So let me delete all this previous configuration. And also I go in the interfaces. I'll delete the all previous configurations because we in previous session we have done some lab. So I can delete the interface. The all configuration is going to be wiped out. Similarly, I delete this interface configuration and then after I'll make the commit. Okay. So now let me do the zones as well if it is created somewhere. Yeah. So these two zones are created. So let me delete and I'll make the commit. So this firewall have no any configuration related to layer 2 deployment. So what is the layer 2 deployment? First we have to understand. So let me open two PCs as well. So in this PC, you can see that we have the same subnet IP in the both side of the firewall. and they are segregated with the two different interface. So by default, my firewall is going to act as a switch, pure layer 2 switch. And when my firewall is going to act pure as a layer 2 switch, that is known as a layer 2 deployment. You can think in this way. Let's suppose I have the one switch, and this is my layer 2 switch. This layer 2 switch have two clients connected here. This client having the IP address, this is the A client, this is the B client, PC basically. And this having 10.10.10.11/24. This is connected on this. This is your port gig 0 by 0, you can think, and this could be the gig 0 by 1. So you guys tell me, if this is the brand new switch and I just connect the power cable, okay, probably in last class I asked this, so who all are aware, just ignore this. I just give the power supply. These ports are already in no shut state, okay. So will they going to communicate to each other if I configure the IP address on these two PC or not? Anyone?
No, we need to shut the. We need to on that interface. No?
What interface?
That switch interface. We need to power on that interface first.
Yeah, power on the interface, no shut. I have done this. Cable is connected. I make the interface a no shut. Okay, so this interface is up and working. Up state. This is also up state.
Yeah, we need to configure the gateway in our PC, then only it will communicate.
This is only layer 2 topology. Okay, this is the completely layer 2 environment. Okay, these two IP is configured here. Think about it. I want everyone should try to give an answer. I want to see your basic networking understanding. Amit, probably you can hold down for time being. What are others? I want to know from Tarun, Trilok, Ram, Rahul, Parth, Suresh, Lloyds, Chandu. Please, guys, give me the answer. Will they going to talk or
So
not?
this 10.L2 switch and this is 10.1/24. Now both are /24.
Yes,
right?
both are /24. IP client is assigned. This is the brand new switch. This is a brand new switch. I just connect the power cable on this brand new switch. No other configuration. I just connect the port no shut, up stage, port no shut, up stage. I just assign the IP address of the machines. So will they going to communicate?
On
Yeah,
VLAN
they are.
1, it will go.
Yeah,
Yes,
they
they will
communicate.
communicate. Broadcast will be done.
By default, they are communicate.
Why they are going to communicate? Any logical answer?
Due to same VLAN, sir.
Which VLAN is there? I didn't configure any
But-
VLAN.
See,
Okay.
both the PC are in native VLAN. That's why they will communicate.
Very nice
They
answer.
are in native
So what is the
VLAN.
native VLAN IP address?
Secondly,
Who
they
answered
have the
this?
same native
Who answered?
VLAN 1.
Rahul, you answer, right?
So
Good job. So basically, by default, every switch which you're going to purchase from the market, they always stay in the VLAN 1, which is known as a native VLAN, right? And if you are not even configuring any access port or any other additional VLAN for the 10, by default, they are going to belong in the same VLAN. So if they are going to belong in the same VLAN, so they are going to talk. There is no port because they are going to stay in the same broadcast domain. All right. The broadcast domain are same. So the communication is going to happen due to the VLAN 1 configure your switch port. Let me show you this configuration. So just assume these two port on this switch. This is a brand new switch. So let me show you the same concept so you can understand. So let me open this switch. Okay. Understand these two ports, right? 0 by 0 and 0 by 2. So if I'm going to run this command, okay, by default, I believe, let me do one thing. Let me wipe the switch configuration. Already there is some default configuration is there. Then I'll show you. Hold on for a while. So let me open this switch as well. Okay, so now we don't have any configuration on this switch. So if I go here and if I run the command, this is a brand new switch, so VLAN brief. Okay, so saying every ports right now it's showing in the VLAN 1 by default. So these two ports are going to stay in the VLAN 1. So that's why, let's suppose this PC is connected here on this interface instead of firewall, they're going to communicate. Same logic is going to happen. So in this lab, what we're going to test, you can see this is the layer 2 switch here. This is the layer 2 switch here. This PC is going to connect this switch. This PC is going to connect this switch. This switch is going to connect the firewall. This switch is going to connect the firewall. This interface also going to layer 2 interface. This also interface going to layer 2 interface. Then our end-to-end traffic is going to happen via the firewall and completely layer 2 communication. So this firewall is going to act as a switch. You just have to process and deploy the layer 2 method to applying the real-time configuration between the source and destination. Okay, so this is a layer 2 deployment. So let's understand how it is going to be happen. Let me know guys if you have any questions. So what I'll do first, I make these two ports under the VLAN 10 and I use end-to-end VLAN 10 instead of the 1 because it looks very native. So I'll create my own VLAN so you guys can understand how it is going to happen. So I'll go in the switch first and I change the host name. So config t and host name is a switch 1, right? I create the VLAN 10, right? After getting the VLAN 10, I'll just assign these two ports. This is the Ethernet 0 and 0/2 as a access port and assign the VLAN 2. So interface Ethernet 0/0 switch port mode access, switch port access VLAN 10 no shut. The another port is interface Ethernet 0/2 switch port mode access, switch port access VLAN 10 no shut. So if I go and run show VLAN brief now, so my these two ports have been changed under the VLAN 10. You can see Ethernet 0 and Ethernet 0/2. So right, it's the correct. So let me write the configuration. The switch configuration has been done. Similarly, on the switch 2, I have to make the Ethernet 0/1 and 0/2 under the VLAN 10. I have to get the VLAN 10 as well here. So I'll go on the switch 2, configure the host name. This is the switch 2, VLAN 10, right? And interface, I use the range command, Ethernet 0/1 to 2. Let me see, this is the correct interface. Yes, 1 and 2. And one go I am configuring these two interfaces, switch port mode access. Okay, switch port access VLAN 10 no shut. Okay, do right. So if I run this command show interface brief, you can see these two ports are also part of the VLAN 10. We done. Now we are going to check whether this PC have the correct IP address or not. So probably they will have the correct IP address, but we can verify. How we can verify? You can go in the network settings, and after going in network settings, sorry, not here. You just have to click in the right click and go in the properties, change adapter settings and click on these properties. After going that, you have simply go here and check. This is the network IP is configured, this particular. There is no gateway because the layer 2, so they are going to stay in the same broadcast domain. One more thing you have to do that, you have to make sure firewall is disabled on the PC. How you can disable? So you can just have this right now, you can see all firewall is off. So it should be on in normal scenario. So you should just make it off. So all the firewalls should be disabled on your PC. Because by default, if you're not going to disable, ping is not going to be work. So that's why if you want to do the ping test, so you disable it. It's recommended in the lab environment, not in the actual, because this PC, legacy PC, the ICMP is blocked. Similarly, in the Windows 2 PC, let me see here. Okay. So if I go here in the Windows 2 PC, properties, change adapter settings, LAN properties, and you can see this is also configured. So this is also good, right? So now if I'm going to ping from PC1 to PC2, the ping is not going to work right now. Okay. So if I just trying to ping, it is not working. Similarly, if you ping the from another side from, hold on, what happened? Just give me 1 minute, it's a little bit slow. Wait for a while, let me see why it's slow. Just give me a few minutes, I'll fix this. Okay. So CMD, I'll just go and try to ping 10.10.10.10 minus T. It is also not pinging. So from one PC to another PC is reachable and vice versa, it is also reachable. So we are not able to ping, but we have to make sure they should be pingable to each other. So for that, we have the firewall in between. So we have to make sure like the firewall should be also configured, and then after it is going to work for you. Okay, so how the firewall is going to be configured, we have to understand step by step how the firewall is going to be configured. All right, so let me go and do the firewall configuration. So to configure the firewall, first you see that there is two options. What I can do, I can simply duplicate this and I can make this zone as a like, hold on. So this could be the LAN to LAN zone. So in this, my both source and destination are going to stay in the same zone. So what is going to happen? If I do the VLAN configuration, they are going to talk to each other or not?
Yes,
Is it going to talk?
better. Yeah.
Yes.
It is going to talk, right? So let me do that without any policy, without any additional configuration. If I just map these two interfaces in the same VLAN 10, then zone is going to be same. So by default, they are going to talk. So let me do that and we'll see whether it's working or not. So I'll go on the interface configuration. After going in the interface configuration, what is my interface? That is Ethernet 1x1 and 1x2. So simply I'll go on the Ethernet 1x1. First thing it is asking, what is the interface type? So we have the multiple type of the interface. We have the tap mode, HA mode, virtual wire, layer 2 and layer 3. So right now we are talking about the layer 2 interface type. So I simply go and select the layer 2 interface type. Once I select the layer 2 interface type, they are asking about what is the VLAN ID you want to assign. So in Palo Alto, actual VLAN ID, it doesn't matter, right? One thing is going to matter, whatever the name or number you are going to give this interface, that should be the same. It's not necessary whatever the switch you configured with VLAN 10 or here VLAN 10, that is local to the switch. But firewall, the number or name you are going to give the one interface as a layer 2 should be matched to another interface to just process the same set of the traffic. So you can use the VLAN 10 or you can use the any name, number, whatever you want to do that. But best practice, use the same VLAN ID, means the 10 number. Okay. So let me do that. So I'll go here on the configuration and I'll create the VLAN. VLAN can be created here and VLAN can be created here as well. So I'll show the both of the option when I create for the another VLAN in next lab. So I go here and create the VLAN. So it's already 10 is created because we forgot to delete, but let me create this time. Hold on. So let me go here, remove this VLAN. Okay. And let me go here again. And now I'm going to create the layer 2 interface. And I'll just go and create the new VLAN, right? So I can put the VLAN is the VLAN 10, or I can just give the number as well. Anything it is going to work, number or name. So I just create, no other configuration is going to require. That's done. Security is very important. Okay. So I mentioned every interface must be mapped with the security zone. This is the what we're trying to understand in different lab scenario. So on this interface, I'm going to associate with the security zone as a LAN zone. So simply I go here and create one of the security zone as a LAN zone. I can create security zone here or here as well. You can see. So here I can go and create the security zone as a LAN zone. I click OK. No other configuration. Done. Similarly, for the layer 2 interface, which is configured on the switch to Ethernet by 1/2, I'll go here. And after going there, I just go and layer 2, just VLAN, same VLAN 10, security zone again the same. Okay, because in the first scenario I was thinking the same security zone, and we'll try to change the security zone as well. So now it's done. So my configuration is done, and I'm not going to do any policy configuration. So what is going to be happen? They have the default security policy, inter-zone and the intra-zone. So it is going to hit the inter-zone or intra-zone. What is the correct answer? It is going to hit the intra-zone or inter-zone?
Intrazone. Intrazone.
Intra-zone, right? The same zone. So if you see in the intra-zone policy, in intra-zone policy, if you go in the right side, you see everything is allowed. This is the region by default with the same zone, communication is always going to be allowed. So right now it is not pinging to each other, but once the commit is going to be happen, they should start pinging. Let me see. So these two PC are not pinging right now, but let's wait to just commit the changes. Anything you are going to apply, you must commit it. Without commit, it is not going to work. So probably see, they start pinging to each other without any policy configuration. Why? Because they are hitting the default policy which have the intra zone and everything is allowed. You can see start getting the hit counts also on this particular policy. If I just reset it, you are going to get the new hit count. So now it's a 0. And if you refresh after some time, this hit count is going to be increased. So wait for a while. We'll get the hit counts on this particular, because this is going to process the packet. It will take a little bit time to update the hit counts. So probably we can see meanwhile here, session browser, the traffic is processing via the firewall. You can see the traffic is coming from the LAN zone and it is going to LAN zone from this address to this address, and this is the ping type traffic. And it's hitting the rule as an intra-zone default. You can see even the rule name. So that's why this is going to show you the hit count after some time. Definitely it is going to be updated. So we'll see the real-time hit count as well. It probably take 5 minutes to update sometime at virtual firewall. So little bit take a time, but you will see the hit count likewise earlier. Okay, so now we understand because of this intra-zone policy, our packet is processing and we can see the real-time hits also, which policy it is hitting. Right, and the traffic is coming from the ingress interface is the Ethernet 1/1. See, this is the interface, and exit via the Ethernet 1/2. So this is also very much clear to us. All right, clear to everyone? So if we have the same zone, then we have the policy is going to hit the intra-zone policy. But if we have the different zone, then this traffic is never ever going to be processed. This traffic never ever going to be processed. Okay, so still no hit count. So it will come, definitely it will come. Wait, meanwhile we just do the labs, we'll see the hit counts will be there. It will update at later stage. So what is going to happen? Let's suppose I'm going to change the LAN zone as a trust zone. Okay, So if I'm going to change the trust zone, then I have to change the firewall policy as well. So what I have to do that, I have to go on the interface, and this interface, whatever the interface Ethernet 1/2 we have to change the zone name from here to here. So I have to go there and I have to change the zone name as a trust zone. Okay, once I do that, I click it and I just go and do the commit. My communication is going to be stopped anyhow, because now the zone has been changed, so their traffic is going to hit to the different policy, that is the inter-zone policy, and because of the inter-zone policy you're not able to process the traffic. So let's wait for a while and we'll see this communication is going to be stopped between these two devices. So you see, almost commit is done, and you will see that the packet getting start RTO, request timeout. This also start getting the request timeout, because why they start hitting the different policy, that is a, see now the hit kind also updated for the first one. 538 packet, it was a process, it take a time, but hit count was updated. See, but now the packet start dropping because they are start hitting the inter-zone policy. So now if I want to allow the communication between these two zones, I have to create some new policy where I have to allow the traffic bi-directionally. Means if I am the initiator, so my traffic will go from LAN to trust. So my one policy is LAN to trust. Okay. If this is initiator, then another policy will be trust to untrust. This is the thumb rule you have to apply. Who is the initiator? From that perspective, you have to check whether I have the policy or not. If you are going to apply one side policy, this PC can ping to this PC, but this will never going to ping to this PC, because you also need the reverse policy. So what I can do, I can go in the firewall and I can create the new policy. The first policy could be the LAN to trust policy. And in this LAN to trust policy, I'll just match the LAN zone source address. You can just give any, just single IP address, or might be the whole subnet. Let's give the single IP address because we are creating the one-to-one communication trust. For destination, I'll go and give the 11. Single host it is going to take. Action is allowed. Just create the one policy. Another policy we have to create, the trust to LAN zone. So the reverse is going to also work for me. Trust to LAN policy, and this time it is going to, source zone is going to happen trust address is going to be 10.10.10.11. destination zone is going to be your LAN. Address is 10.10.10. application action category allow. All right, so now we created these two policy and we have to commit it. Once we commit, we'll see these two devices start talking to each other again via the layer 2 deployment, because earlier zone was changed, so inter zone policy was not there, same zone policy was there. That's why when the same zone was configured on the both interface, they were talking. But because we changed the zone name, they don't have the policy because they start hitting the inter-zone policy, so they stop talking to each other. So we just have to make sure we have the right policy in place. So wait for a while. Once the commit is going to done, it is going to start working. So probably you can see they start pinging to each other. Almost it's the commit 90%, 99%. So these PC start talking to each other. Let me see this window, and this is also, they both start talking to each other. And if you want to see in the live traffic event, so session browser, even in the traffic section, you want to see the live traffic, you'll see that the traffic start showing here in this also, because this is a license firewall. So you can see the traffic start showing, the trust zone to LAN zone traffic start showing, source and destination also, and the what type of the policy they are hitting, what byte of traffic they are saying, what type of the application they are accessing, the ping application. So everything is like, you can see that what time it is, right? And the all are processing here. Okay, so any question regarding this layer 2 deployment? Is it clear to everyone? Let me know, guys. Layer 2 deployment clear to everyone?
Yes, sir. It's clear.
Okay, let me stop this lab. You guys, meanwhile, if you have any question, please feel free to ask me. I'll try my best to answer. We have to understand another mode of deployment. Let me start vWire. Okay, so what is the vWire deployment method? So let me just wipe this node and wipe this node as well. I'll start this one, this one, this one, and this one. So let me stop this recording also, or let me just go with this recording only. So what is a vWire deployment? All right, so if I talk about the vWire deployment, let me go down. Okay, so virtual wire deployment, this is another method. Probably layer 3 we know that, layer 2 is the VLAN, layer 3 is the your IP address configuration, but vWire is something new. We'll discuss layer 3 because we have to do a lot of configuration on the layer 3. 99% configuration we are going to do on layer 3 mode only. So in vWire deployment, what is going to happen? Let's suppose you have the firewall and you have your LAN network and you have your WAN network. Your all communication is happening through LAN to WAN, but there is no security in place. There is some requirement, you don't want to change your LAN WAN IP address, means your the ISP IP address, and another side your connected ISP IP address, means you don't want to change your WAN IP address schema for any reason. This could be the company integration with a different company, migration strategy, you want to do POCs, proof of concept, right? And you want to just test without touching your legacy network environment, without making any changes in the legacy network environment. Still you want to test all feature of the Palo Alto Firewall. So this is the vWire deployment method come in a picture. Most of the case you are going to find the POC environment where client is going to integrate the Palo Alto Firewall in their legacy systems, and they are going to check whether this firewall, this product is going to meet our requirement or not. So when you deploy in this vWire mode of any Palo Alto firewall, there is no routing, there is no switching. It's a pretty straightforward. Means you don't have to do routing, you don't have to do any switching, but still you can do all kind of the firewall inspections. Okay, so you want to verify the content inspection is going to happen, the virus is going to be inspected, the vulnerability is going to be happen, the DOS is going to be maintained, like DOS traffic is going to be filtered, any file blocking it is going to be maintained, any kind of data leak is going to be maintained, right? Means you are going to protect your any kind of the malicious content which is going to back and through from the firewall. Additionally, you want to apply some kind of the application level control, you want to apply any URL level control, you want to apply some IP source and destination level control, source port, destination port level control, right? User ID level control. These all things are going to be happen through the firewall, except no routing, no switching. These two things are not going to be happen through your firewall. Rest every firewall feature you are going to explore. So let me draw one of the examples so you guys can understand. Meanwhile, this firewall is getting ready. Let me open it. So let them ready. So let's suppose this is my network. This is my LAN network, and LAN network already have the router configured here. Behind the router we have the switch here. Switch have the client connected here, and this is your internet, and this is your plain network. So right now in this network, I'm just giving an example. There is an IP address must be configured. That is a WAN IP address. This could be the 122.16.10.2/30, and another ISP site, it is 122.16.10.1/30. So you're able to ping pong each other. There is no problem at all. This able to ping this IP, this able to ping this IP address. Now this is non-secure network. Why non-secure network? Because there is no firewall in between. But there is a one requirement. You want to integrate the firewall in between your ISP network and between your LAN network. But there is one condition. You don't have to change any IP schema. Especially there is a requirement you have to deploy this firewall in the WAN infrastructure without changing any IP address. Okay. So what is going to be happen? If you don't have to change the IP address, if you're going to change the layer 2 mode deployment, then you have to do the VLAN configuration. So switching come in a picture. So you don't have to do switching as well. If you want to go deploy in the layer 3 mode, then IP going to require. Then it is also not possible. So no switching, no routing. So you have to deploy Palo Alto Firewall as a transparent mode. Right? So you have to deploy in the transparent mode. Means simply it is going to act as a physical cable, layer 1 mode. Like how it is going to happen? Let's suppose this is your firewall. So firewall is going in between. This is your firewall. The cable is going to be connected. This cable is going to be connected. But IP is going to remain same. And this interface going to act as a transparent, and they are going to create some virtual mode tunneling between these two interfaces. So whatever the IP configured here, it is going to ping this IP, and whatever the IP configured here, it is going to ping from here back and forth. And this firewall is never going to stop any IP communication. Any VLAN you want to configure, tag you want to propagate, that is also doable. But if you think this firewall can do the routing, no possibility. Switching, no possibility. This is known as the virtual wire deployment mode. Okay, but still you can do all firewall feature inspection. Like you want to process the traffic for certain application, you want to allow the traffic, you want to deny the traffic, that all possible. One condition is there. If you want to make the vWire deployment, whatever the interface, let's suppose this is a firewall Ethernet 0x0 interface, and this is the Ethernet 0x1. Only two set of the interface, two pair of the interface, one pair of the interface are going to basically make the vWire tunnel or virtual wire between the interfaces. No more than two interfaces going to come in a picture. Okay. So in this our scenario, if I just go in the lab again, let me meanwhile check the firewall is ready or not. It's ready. So job solve. Okay. So auto commit. Let me put commit force. It is going to commit. So 99% commit. So it should be complete 100% commit. Whenever you run the 9.0 firewall, it's going in the auto commit mode. So it is trying to copy or commit the configuration, whatever the available running configuration. It takes a little bit time. So if you leave it, it will automatically complete. Else you can just do the force commit. It is going to happen quickly. So now it's done, right? So let me show job solve. So there is no jobs running, all commit has been done. So I was saying, like, we have the lab topology you can see here. In this lab topology, again, we have the two interfaces, but they are the different mode of deployment. This is a vWire mode of deployment. In this interface, we have to configure the zones. We can keep these two interfaces in the same zone or different zone. If the same zone, there is no policy going to be required. But if I have to use a different zone, the policy is going to be there. Makes sense? So what I'm going to do that, I'm just going to configure this router. You can see this is the one side of the network, ISP, and this is my LAN network. Okay. By default, I have to establish the communication from these two devices, and also I have to do some filtering as well. So let me see if it is doable or not. So I'll simply go in this particular configuration of the router. Let me open it. R1. This R1 have already pre-configured. Let me show you the R2. R2 probably I just remove this configuration. There is no configuration. Similarly, I'll go on the VPC. This is normal PC, virtual PC, right, for just testing. So I'll go on the VPC2 as well. I'll go and assign the IP address. So see how the IP address is going to be assigned on the virtual PC first. So this IP I need to given on this virtual PC 172.16.10.2/24, and gateway is this router. So how I can assign that? I simply go here and I just give the IP address 172.16.10.2/24 and gateway is 172.16.10.1. So this is how you can assign the IP address. So this IP address is going to be assigned, and if you just run the command show IP, this is going to show the IP, whatever the configure. So wrongly I assigned the VPC2, my bad. This is the VPC1 have this. This I'm the 192.168.10.2. So let me correct the IP address. IP address 192.168.10.2/24 and gateway is 192.168.10.1. And if I just check the show IP, this is done. VPC1 again 172 IP address 172.16.10.2/24 172.16.10.1, right? And they are checking duplicate IP address, no duplicate IP address, show IP. This is done. So right now if I try to ping from the one PC to another PC, they are not going to work because we have the different network in between. The C router, Palo Alto Firewall, this again C router. So we just have to establish the connectivity from the R1 to R2 as well, and also you have to configure these interfaces as well. So first go in the R1 and I'll go in the enable mode and I just configure the interfaces first. Okay, which interface I need to configure? Ethernet 0x0 and 0x1. So let me configure interface Ethernet 0x0, IP address 10.10.10.1/24. No shut. Now I have the another IP address need to be configured, that is Ethernet 0x1. So interface Ethernet 0x1, IP address 172.16.10.1 255.255.255.0. No shut, do write. So if I just ping from the VPC1, my gateway should be reachable now. Let me try again. 172.16.10.1 because gateway has been configured. And even I try to ping this IP address 10.1 should be also reachable because they are in the same device and they available as a directly connected network in a routing table. So if I just try to ping 10.1.1, it is also going to be reachable. But still 10.2 is not going to be reachable. So this is reachable, right? But 10.2 is still not configured, and 10.2 traffic must be processed by the firewall. So we see how it is going to reachable. So let me configure the R2. So R2 is the new router. So I'll go here and first change the host name as R2. And after changing the host name, I'll go on the interface. And what is the interface ID? That is 0x0 is the first, where 10.2 is need to be configured, and 0x1 192.168 10.1 need to be configured. So let me go here, interface Ethernet 0x0, IP address 10.10.10.2 10.10.10.2 255 255 0 no shut, and another interface Ethernet 0 by 1 IP address 192.168.10.1 255 255 255.0 no shut. Okay, do right. So this is done, but still if you check from the VPC1, right, if I go in the VPC1 and try to ping 10.2, it is not going to work for me. No communication is happening. All right, so if there is no communication between these two PCs, then what next? The next is I have to go, and if I just check from the VPC1 and I try to ping my gateway and 10.2 IP address, this should be reachable. Let me ping from the VPC. See, .2 is self IP address, .1 should be the gateway. The first is ARP drop, it happened, and the packet was dropped. Now the second hope is 10.10.2 in the R2, that is also reachable. So let me summarize what I have checked out now. I configured the IP address, I configured the gateway, I configured this. So from this PC I'm able to reach this, and this PC I'm able to reach this address. From this PC I able to reach this address, and from this PC I'm able to reach this address. But from this PC I'm trying to reach this one, not workable. This one I'm trying to ping, not reachable, because the firewall in between. So we have to do some additional configuration here, and that is the vWire configuration is going to be required here. So let's see how the vWire is going to configure, and then how the end-to-end communication is going to be happen. So to configure the vWire, we require two interfaces. So already Ethernet 0 by 0 and 0 by 2 is there. So simply I go in the firewall, and this time firewall interface was, let me see what is IP address, 158. So let me log into the firewall, 158 HTTPS enter admin so we just need to change the password again for GUI as well. Let me log in with a new password. So now we're done, right? So we just simply go here and we just have to configure the vWire. So simply go on the interface, that is Ethernet 1 by 1 and 1 by 2. And here I will go and select the mode of the interface as the virtual wire. And virtual wire name, I have to define one virtual wire name which should be the common for these two interfaces. I can put the simple name is the vWire. Okay, and interface name showing none. Allowed tagging VLAN, that's default for the all, so I'm not going to change anything, but interface mapping is going to be automatically happen. You'll see that later stage. Click OK, and this configuration of this interface has been done for the virtual wire, but you also have to create the security zone. So for this interface we have the security zone is in zone, and this one have the out zone. So let me create the security zone as well, because the virtual wire also requires the security zone. So I'll put the in zone, and I'll click OK. Now this configuration is done. No other configuration is going to be required. So if you check in the virtual wire again here, so now one interface has been mapped here. You can see. So similarly, you have to map the another interface. So you have to do the configuration for the other interface, Ethernet 2. So I'll go here and I'll just configure the virtual wire. This is again a virtual wire, and the security zone I'll just go and configure that the out zone. Out zone, and I'll click OK. Done. So this is also done, and if I just go in the virtual wire, you can see the both interface has been mapped. Now, what is the most important? Because these two interfaces in and out, so by default, the communication is going to block by the firewall. So you require the policy from the both direction. In zone to out zone to in zone. So how it is going to happen? So I just create the generic policy because a lot of things in have to define the policy in later stage. Let me create the generic policy, allow all. So I'm going to allow the both zone type configuration in the bidirectional. So I'll just put the in zone and out zone in source, means either direction. This is creating, then this is the in zone is source. This is creating, this out zone is the source. So I'm just putting both as a source. And in this destination, if this is creating, the out zone is a destination. So I'll put the out zone. But when this is creating the packet communication, then your zone is the in zone as a destination. So I'll put the in zone as well. Simply it's allow. And once I'll commit this, okay, you will see that my communication start going to happen. But one more thing, the routing is missing on the router. Why? Because this PC is going to reach to this different network. So we should have some routing. So we'll use the default routing here, pointing toward .2. Similarly, if this PC is initiating for 172, that should have the default routing pointing toward this. Then it is only going to work. So routing is required for the R1 and R2 point of view. So let me go and configure the routing as well. Show IP route, just default route I'll configure. 10.10.2, do right. And if I go in the R2, similar, I'll just put the reverse route pointing toward the R1. And do right. This is done. So if you check the show IP route, you have the default routing for the any subnet you want to go, just go in the R1, and R1 have the, if you want to go any subnet, you should go on the R2. So this is the R2, right? So this is also done. Now what we have to do, we have to perform the testing. So let me go in this particular VPC1 because the policy is there. So I'll go in the VPC PC and try to ping the PC, that is a VPC2 168.10.2, and see it is responding. You can see this is responding, means I'm pinging from this and this is working. Similarly, I go in the VPC2 and try to ping the VPC1. So let me go in the VPC2 and try to ping the VPC. This is also pinging. So if I just put in this way -T, you will see that your traffic is available on the firewall, means the traffic is processing via the firewall. But let's say suppose I have a requirement and we have to check this requirement, then vWire mode is going to be completed. Let's say I have the requirement, this PC can ping this address, but they cannot ping this address. This is my requirement, or I can block the ping for this address and allow the ping for this address. Either way I can check. Let me see current situation, what is happening right now. So in current situation, these two address must be reachable. So let me try. 2 is reachable, 1 is reachable. So I want to block .1 communication and .2 should be reachable. Okay, so how the firewall is going to block the communication? Then it is the vWire actual use case. So I'll go in the firewall again and I'll go and create the policy. This policy has everything allowed. So in top of that policy, I'll create the new policy and I'll just say block PC1 to 192.168.10.1. I want to block this address. Okay. So I'll just put the source address. Source zone is the edge zone. Source address is going to be 172.16.10.2 and user destination is your out zone. Address is 192. You want to block 10.1. Okay. This is done and just deny. Okay. But the sequence is more important. We just have to put this sequence on top. So I'll just click on the top. This is going on the top. This is created. Now if I just commit this, you can see. So let me go, the policy is in place in top of that. So if I go here and try to ping now .2, say it is pingable. But now let me check .1 as well. Should be blocked by the firewall. See, it is not pinging. So now my vWire actual firewall just start blocking the traffic. Means there is no routing, no switching, but still I am able to block the traffic. So you guys understand the vWire mode of deployment? Any questions anyone have? All good? If all good, we can conclude the session here. We'll have the another session. We'll means the upcoming session weekend. We'll try to just go, because the most important thing you guys have to understand about the zone, right? Because you missed that. So I wanted to cover the zone. Rest are the easy things I can cover anytime, like the tap mode deployment is just for monitoring. So it is going to understandable. Sub interfaces, virtual router we are going to configure multiple times, so it is going to be understandable, and I'll have the separate session in future also, so we can have the same doubt session and the separate session where you can understand the any kind of the like the concept which you guys not understand during the session. So I just wanted to make sure you understand the vWire deployment, layer 2 deployment, layer 3 will keep doing the configuration. Tap mode is just for the monitoring. So it's simply 5 to 10 minute topic. So I'll explain in later stage, no worry for that. Okay. But zone is the very important. All right. So we are good for here, or any question anyone have? Let me know, guys. All silent.
All okay, sir.
No, thank you.
Okay, sir.
Okay, so let's conclude it here. Do your recap, okay? Do your lab practice, and we connect again for the any doubt.